Hey everybody. So we're going to be jumping into new topic. Well, kind of new. We started it in class, but we didn't get that far into it. We only got to 5.1 and 5.2. So this will be kind of our first foray into new content. We'll be jumping into 5.3, but I don't want to post too much new stuff at you while we're kind of adjusting to this new format of new lessons. So we're just going to look at 5.3 and kind of use 5.1 and 5.2 to review. So I kind of put these deliberately so you can reference it. So at the end of the video, I'll show you guys how to reference each section in the book that I posted online. But for now, we'll go ahead and jump in. So to start, we'll review writing and solving two-step equations, and then we'll jump into writing and solving equations with the distributive property, how to deal with that. So remember, we're jumping into kind of this new way of solving things, algebra. So think of this as kind of like your pre-algebra unit. We set the foundation with expressions. Now we're going to learn how to take those expressions, turn them into equations and algebra. And basically what we mean by algebra is we're going back to kind of what the Persians figured out, is that they can reunite these equations and kind of like manipulate them, and they call that process the reunion of broken parts. And as we kind of delve into this, that'll come a little bit more obvious. So let's jump in. So we're going to start with a problem we've seen before, and I want to keep it the same because that way you can kind of reference back. But we're going to look at the Charlie Tucker golf ball problem. So we got Charlie. My dog has nefariously collected a bunch of golf balls, but Tucker's a little farther ahead. So if we look at this, we see Charlie's got one bucket of golf balls. Tucker's got two full buckets of golf balls, plus three more to the side that aren't in a bucket at all. And so now it kind of formalized a little bit. It says Charlie collects golf balls. We see that here. And I better change this because they misgendered Charlie. Her neighbor Tucker collects three more. So this is like the plus three here. Then twice as many golf balls as Charlie. So think of this as like a Charlie bucket, two Charlie buckets. It's kind of like twice as many. And then three more. So really kind of drove the point home with graphics. So the way I can think about this is let's start with our bar model, and we'll deal with this last bit of information in a second. But if I take one of Charlie's buckets plus another Charlie bucket plus three more, then we can basically say that that's equal to the number of golf balls Tucker has. So I'm going to say that that whole portion is equal to this length here. So we can say that if C is the number of golf balls Charlie has, then T is the number of golf balls that Tucker has. And so this is all equal to T, or 143. So if I take one of Charlie buckets plus another Charlie bucket plus 3, I get 143. So what I'm communicating with these links here is that these quantities are equal. So what I can do from that is I can make an equation. So I've got C plus 3, and that's equal to the total that Tucker has, which is 143. And why don't I clean this up? I got some like terms I can combine. Let's combine C plus C to 2C, and I got 2C plus 3 equals 143. So we've got writing two-step equations down. Let's jump into solving them. So I'm just going to copy that equation over to my other slide. We got 2C plus 3 equals 143. So now we're going to look at solving this. So of course you could kind of like reverse engineer this, but we're going to learn the algebraic method that will allow us to solve much more complex problems than this. So we're going to build a framework here. So remember when I said that you could basically undo all the steps here. Again, we're trying to reunite the broken parts. This C is broken up into a times 2 plus a 3, and that equals 143. But I don't want all that. I just want to know how much is in one of these buckets, or my variable C. So remember we said we could reverse PEMDAS. So the way I like to think of this is like if you're building a Lego structure, and you've got all these pieces set up, and you need to tear it down, you're not going to start with the first piece you place. You're going to start with the last. And you're going to sort of peel them off until you've gotten back to the beginning. So we're going to do the same thing here. We're going to try to peel everything away. So think of this as we're going to reverse PEMDAS, or we're going to SAD map it. So essentially, if I see subtraction and addition, I want to undo that first. Then I move down to my division and multiplication. Then I move down to my exponents and my parentheses. So let's SAD map it. So essentially what I'm going to do is, if I see any kind of addition and subtraction, I'm going to undo it. So I see a +3 here. Let's undo that. Let's subtract 3. And remember, it's an equal sign. It's like a teeter-totter. As long as I do the same thing to both sides, I have not changed this equation. I've only changed what it looks like. So I subtract 3 from both sides, +3 minus 3. That's 0, so that goes completely away, and all I'm left with is 2c on the left-hand side. On the right-hand side, I'm left with 140. So now I don't see any subtraction and addition, so done those steps. Let's see if there's any division and multiplication to be done. So I don't see any division. Multiplication, remember we said we got a number times a variable, that's like 2 times c. So I've got multiplication here. I can undo it with the opposite operation, division. So I see a times 2. Let's divide by 2. 2 divided by 2 just goes away. And now I have c is equal to 140 divided by 2, but we could just do that math. 140 divided by 2 is 70. And that says Charlie has 70 golf balls. And you don't have to do this every time, but I'm going to show you how to do a check step really quick. So let's just check if C does indeed equal 70. So all I'm going to do here is I'm going to take my original equation. I've got 2. I'm going to color code this so it really is kind of obvious what I'm doing. 2C plus 3 equals 143. So all I'm going to do to check this is I'm going to take my solution, C equals 10, and I'm just going to plug it back in and see if I get a true statement. So does the left-hand side equal the right-hand side? If it does, pretty confident in my work. So I'll just plug in where I see a C. I know what that value is. C is equal to 70. And I'll work this backwards. 2 times 70, that's 140, plus 3 equals 143. And let's just carry this to our completion so we can kind of prove it. Like, it looks like it already, but 140 plus 3, we get 143, and we just show that, prove it completely for everyone to see. We got 143 equals 143. Gosh, is that true? Yeah, we know it's true. So put a big old check. We've checked our work. Charlie does indeed have 70 golf balls in her collection. All right, so now we got done our writing and solving two-step equations. Let's jump into, what if we have something with the distributive property? So this is a problem that I kind of wrote myself, so it won't be in the book, but you've got quite a few kind of examples that you can use for this as well. But this way I can kind of move things around. So let's say you and your friends go to the movies. So say you and 2 friends. So this would be you right here. You've got your ticket and your popcorn. Here are your 2 friends. So each of you also buys a soda each. So you got your movie ticket, you got your soda. And we've got a little bit more information. So we don't know the cost of the ticket. So we're just going to label that T, cost of ticket. But we do know the cost of the sodas. The sodas cost $5 each. So this is 5, this is 5, this is 5. And we also know one other bit of information. We know the total bill is $43.65, and I made that kind of draggable here. So we're going to try to leverage all this, and we're going to try to figure out how much does one ticket cost. And we're going to try to do this with the distributive property. So there's a couple different ways you can do this. So this is a problem you can actually do without the distributive property, but I'll show you why it kind of becomes annoying in a second. So I could turn this into an equation. I could say, well, I've got my total bill, and that's just equal to everything I bought. So I could just say, and actually let's group this by person. So we've got you here on the left, you buy a ticket, you buy a soda, you get your friend here, and then you've got your second friend here. So I'm going to turn this into an equation here. The total bill is equal to everything you bought. So you get your ticket plus your soda plus another ticket for your second friend plus another soda for your second friend plus a third ticket plus a third soda. And we could say this is like t plus 5 plus t plus 5 plus t plus 5, where like this, let me color code this real quick. So like this corresponds to my ticket plus my $5 soda, my ticket plus my $5 soda plus my ticket plus my $5 soda. But you could see that if I had, let's say this is a problem where you were trying to get 30 people packed into a movie theater. Writing out t plus 5 30 times would quickly become exhausting. So we're going to try to figure out an easier way to do this. So what if I said instead, let's group this a different way. So I'm going to instead look at this where I've essentially got 3 sets of the exact same thing. So I've got a ticket plus a soda, and I have 1, 2, 3 sets of these. So what I'm instead going to do is I'm going to write this as, and I'll kind of draw a line through it, show what I'm doing graphically, how I'm relating it to the equation. But essentially what I have is I've got 3 sets of t plus 5. And that's going to equal my total bill right here. So the key thing here is, well, we just learned that, well, if I see an equation like this, I've got a reverse order. And so the tempting thing would be is to say, well, I've got a plus 5. Oh, geez, I better subtract 5 from both sides. However, this isn't just a 5. This is a 3 times 5. So what I'm going to advise you here is once I've set up my equation, or if I get an equation that I haven't set up, but I'm sort of given it, what you're going to want to do is before any of this, so before you SADMAP at all, just deal with any distribution. So that'll be step number 1. Then you deal with any of this. So we'll deal with our distribution, and then we'll start reversing order. So what I'm going to do first, since this isn't actually a 5, it's a 3 times a 5, so I'm going to apply my distributive property we worked on last week. So go ahead and draw my arrow, and I have 3 times t, which is just 3t, plus 3 times 5, which is 15. And that's going to be equal to 43.65. So now, at this point, I can just reverse the order. So I've got addition and subtraction. I'll take that plus 15. I better undo it with the opposite operation. I'll subtract 15 on both sides. So that cancels out, and we'll just do that math really quick. We got 43.65. Let's subtract off 15. That gives us 28.65. So I get 3t equals 28.65. And now, dealt with my addition and subtraction, let's deal with any kind of division or multiplication. So I've got multiplication here. Again, let's undo with some division. So divide by 3, cancel that out. And now I just take 28.65. Let's divide it by 3. And we got our ticket is equal to 28.65 divided by 3, which we found that to be $9.55. So ticket costs $9.55, and we've solved our equation. So again, to kind of recap, if you see any kind of distribution, any whatsoever, just distribute first, combine like terms, and then do your equation steps. So One thing I want to give is just in case, like maybe this hadn't quite landed yet, which totally okay if it does. I'm posting like some extra resources on the Schoology page. So what you can do is, again, I've referenced this to 5.3. So if you go to my Schoology page and you hit this materials button here, what I've done is I posted kind of PDFs of the workbook as well with extra examples. So this was topic 5 equations. Click here and you've got a workbook. So you actually should have, it doesn't have the beautiful Charlie on it, but you'll have kind of a further example on how to kind of write those equations, a few more examples, some more two-step equation solving, and some extra stuff and examples on this solving problems with distributive property. So hopefully that was helpful. I'll see you guys in office hours this week. Have a great week. Take care.